Hey students, let's do the credible Hulk. Here we go. I have two solutions exposed to gamma radiation. Solution A is 3% radiation power and solution B is 9% radiation power. How many milliliters of each solution will Dr. Banner need if he wants a 500 milliliter solution at 7% radiation strength? Okay, so here's the first part of this system. We need to make two parts, and we've already previewed this from a while ago, but here we go. So to make 500 milliliters, let's go ahead and say solution A is X and solution B is Y. So to make 500 regular milliliters, you would need so much of X and so much of Y to make 500 milliliters. The first part's pretty easy. Okay, again, when you're making these dual systems, or these systems with two conditions, one of them normally just talks about the total amount of things. All right. Now the second one's going to be about the details of the total. So here we go. Solution A is 3%. So now we're talking about the radiation power. So 3% as a decimal would be 0.03x. Okay. 9% radiation power would be 0.09y. And here's the tricky part. You want this 500 milliliter solution to be 7% strength. So watch this. 0.07 times the milliliter. You want 7% of the 500 milliliters to be radiation, or of radiation strength. So whatever. Kind of making this one up. It's not really a real thing, but hey, it's make-believe. It's all good. So there you go. So literally that's it. So here's the total, and here's the percent, all as decimals. These ones are actually pretty easy to make. Basically just copy and paste the first one, and then you just sprinkle on the decimals to each piece. So they're actually very, very easy to manipulate. Okay, it just sounds complicated. Make sure you're careful when you're changing your decimals and your percents around, right? So I've already gone to Desmos and I've already graphed this. So ready, set, there it is. Okay, so there's my 2x plus y equals 500, 0.03x, 0.09y, 0.07 times the 500. And it looks like 166.6 repeating and 33333 repeating. Okay, so to the nearest whole milliliter, to the nearest milliliter, the 1.6 repeating would actually become, I would need 167 milliliters, and then only 333 milliliters of solution B. So this one would not be very fun to solve by making opposites, so please don't. I mean, you could try. I mean, you could take this top equation times a negative 0.03, so you'd make opposite x values. Blech, gross. I mean, that wouldn't be awful. You just have a lot of small numbers to work with. This one I would definitely solve by graphing. So make the system, graph the system. Again, the most mistakes people are going to make is this part. Make sure you take the final strength needed times the total again. And then that's about it. All right, that's the credible Hulk.